Hello and welcome to this Alfa Laval webinar. My name is Magnus Rieger, Head of Market Communication for Business Unit Energy Separation. And I welcome you all, and I'm really happy to see that so many have joined. And I hope that we will get a lot of questions during the webinar. And if you have a question, don't hesitate to write it down on the chat, and we'll try to answer the questions after the keynote presentation in our Q&A session. Today we will be focusing on a really important matter, and that is mining tailings and the dewatering of tailings. And for that reason, we have actually invited our expert in that field, Amol Chinchankar, who will go through his keynote speech he made a couple of weeks ago in our conference at IMARC in Australia. Where we will talk about different techniques that can be used for dewatering, but of course focus on how we can support you guys in the mining industry the best possible way. So now over to you, Amol.
Thank you, Magnus, and hello to everybody. I would like to first give a brief introduction about Alfa Laval. Alfa Laval is a Swedish company with a history of more than 130 years, and today we are a world leader in solid liquid separation, heat exchange and flow technologies. Alfa Laval has presence in more than 100 countries across the globe with a total employee strength of more than 16,000, and today we enjoy a turnover in excess of 4.2 billion euro. I'm today going to talk to you about safe and sustainable tailings management using solid bowl centrifuge. This is a real life story about a coal washing plant in Australia by the name of Rixs Creek. Rixs Creek produce both thermal coal as well as coal for steel industry, and they have been exporting their products to various places across the world. And in their washing plant, the tailings that are produced were being sent to tailings dam. However, a few years ago, the existing tailings dam ran up to full capacity, and at that time they did not get permission from the local governmental authorities to go for another tailings dam. So they were on the lookout for a suitable technology for dewatering their tailings to dispose them off. And that's when they evaluated 4 different technologies and finally chose Alfa Laval's solid bowl centrifuge for dewatering their mine tailings. So I'm going to talk to you about Rixs Creek. So the tailings dam at this Australian customer, it was nearing maximum capacity, and that's when Alfa Laval came into the picture, as I said. And Alfa Laval supplied them our solid bowl centrifuges to dewater the tailings. This gave 2 benefits: recovery of water, which is a scarce resource in that part of the country, and they could also get dry solids for open cut rehabilitation. So by doing this, the need for a tailings dam was totally eliminated, and the operation became much more safer due to that fact. This is the solid bowl centrifuge that I'm talking about. This picture shows the largest centrifuge that Alfa Laval manufactures, and this is a 1000 millimeter bowl dia machine, which has quite a high capacity, and I'll talk more about that as we progress further. So just to take you on the journey that took Rixs Creek towards safety and sustainability in their operations. In 2013, Rixs Creek evaluated various dewatering technologies to handle their mine tailings. And as I said, they chose Alfa Laval solid bowl centrifuge technology. In 2014, Rixs Creek procured 3 centrifuges of 720 millimeter dia each, and with that experience, I mean, running those machines successfully over a period of few years, they were still at that point in time sending part of their tailings to the existing tailings dam. And finally in 2018 they had to stop sending all the tailings to the tailings dam. So that's when they decided to invest in 2 more Alfa Laval solid bowl centrifuges of 1000 millimeter dia, the biggest one that we manufacture. And those machines were commissioned in the 3rd quarter of 2018, and since early 2019 the customer has stopped sending any tailings to their tailings dam. So that's how the tailings dam at Rixs Creek was made redundant. So this slide shows the feed, which is the fine coal tailings with around 25 to 48% of solids in them, and that is being fed to the decanter centrifuge. And from the decanter centrifuge there are 2 products. One is a spadable or stackable solids cake with about 62 to 68% weight solids, and we also get water with say less than 0.5% solid. So the water quality is also quite clean, as you can see from the slide. So Rixs Creek is now able to recycle all that water. Earlier it was going along with the tailings to their tailings pond. Coming to the specific performance of the dewatering technology, each centrifuge has a feed flow rate of 150 to 210 meter cube per hour with a feed solids concentration of 30 to 45% by weight. The total solids mass to each machine is around 65 to 74 tons per hour, and the cake dry solids range between 62 to 68 weight percent, which is quite dry, as you can see from the picture here below, which shows the solids cake coming off the belt conveyor that is falling down from the decanter centrifuge or solid bowl centrifuge. The particle density in this coal tailings is around 1500 kg per meter cube, with a particle size D50 of around 20 microns, and most of these tailings consist of fine clay particles. So they had actually tested some other dewatering technologies such as filters, belt press, geobags. However, they found that the solid bowl centrifuge was the most efficient. So let's have a look at the benefits of the solid bowl centrifuge. As we just saw in the previous slides, the centrifuge can help avoid tailings dam, which is a major concern these days, as everybody is aware. It produces a stackable solids cake, which is easy to dispose of, and then there are a lot of savings in terms of process water recovery, because water is becoming more and more scarce resource nowadays. There are savings in terms of wash water. The decanter centrifuge or solid bowl centrifuge is has a very small footprint as compared to other competing dewatering technologies. So the cost of installation is also much lower, and it's a real continuous separation device in the real sense. Because the machine takes getting feed continuously, and it gives out solids and liquid separately in a very continuous manner. And another advantage with the solid bowl centrifuge technology is that it's a clean and enclosed operation. So the installation is quite neat and clean, and it requires very less operator intervention because it is equipped with state-of-the-art automation. and it gives lower power consumption as compared to many other technologies, and all in all the solid bowl centrifuge has a lower life cycle cost. And apart from coal, the solid bowl centrifuge is also used for dewatering of other metallic tailings such as gold, copper, iron ore, bauxite. Typically, I would just like to give you a brief idea about the performance on metallic tailings. Typically, the feed solids to the centrifuge are in the range of 30 to 40% by weight, and the centrifuge produces a solids cake in the range of 80 to 84% by weight, which is pretty dry. The D50 of the feed particles ranges from 14 to 30 microns, and the separation efficiency is more than 95% almost in every case. So this slide shows one of our centrifuges on gold tailings, and the other picture is that of a centrifuge which was put for a test on a platinum mine. Initially, the customer thought that they don't need to elevate the machine, although we had advised them to keep it at an elevation of around 4 or 4.5 meters, so that the solids discharged from the centrifuge can be collected in a truck standing below it. But the customer thought that, well, this looks like a small machine, so they could easily handle it with a wheelbarrow or manually. But when we started the test, and this is how it produced almost a small mound of solids. So this picture gives an idea about how much solids can be handled through a small machine, through a small solid bowl centrifuge. And then continuing to talk about the centrifuge applications in copper and molybdenum, we have identified three. Apart from tailings dewatering, we have identified three positions for the solid bowl centrifuge. One is, of course, the overflow from the concentrate thickener, copper concentrate thickener. The second position is the wash water from the Larock filter, because a lot of fine copper actually bleeds from the Larock's filtrate, and those solids can be recovered by using an Alfa Laval solid bowl centrifuge. And similarly, there's one more position where the molybdenum concentrate thickener, that overflow also loses some solids, molybdenum particles, which can be recovered using our solid bowl centrifuge. So let's take a closer look at these three applications. When it comes to the copper concentrate thickener overflow, the feed contains around 0.5 to 1% weight by solids, and the decanter centrifuge then recovers the solids to produce a cake of around 85 weight%. You can actually see a picture of the cake when we did a test, and it also helps in recovering the water. So even though the feed contains, say, less than 1% solids, it is still a lot of money for the customer, and we are helping the customer to recover all that copper, which otherwise would have gone to the maybe to other parts of the plant or to the effluent treatment. And then we also have the Rixs filter, which uses a lot of filter wash water, and that wash water typically contains around 3 to 5% weight solids, which can be recovered with the help of our solid bowl centrifuge to produce an 85% cake and recycle the water. And then finally, the molybdenum concentrate thickener overflow, which bleeds a small amount of solids, but even those can be recovered using our centrifuge. So you can see from these figures that in the case of the copper concentrate overflow, our centrifuge can help recover almost 4,500 tons of copper per annum, and that's a lot of money. And similarly, our centrifuge can recover around 7,000 tons of copper concentrate from the wash water of the Rixs filter per year, as well as around 250 tons of molybdenum concentrate from the thickener overflow per year. So that's a huge amount of recovery, and it directly adds to the customer's bottom line. So it really makes sense for them to do that. And then I would like to give you an idea about what are the kind of tonnages that can be handled using our solid bowl centrifuge, because many times the mining people, they think that maybe the centrifuge is not big enough for their operations, but we have an installation in Canada on mature fine tailings from an oil sands operations, and there our centrifuges are dewatering 30,000 dry tons per day of tailings every day in and day out, and this has been going on for last more than 8 years. So it's a very big installation consisting of 18 units of our largest solid bowl centrifuge, which is the 1000 millimeter bowl. And it's a very difficult duty, by the way, to dewater. It's very difficult to filter, and after a lot of testing and evaluation, the customer finally settled on our solid bowl centrifuge, because the mature fine tailings contain a lot of clay. It contains a lot of bitumen, apart from the water, of course. So the solid specific gravity is in the range of 2.6, 2.7, and there are different types of clay particles like kaolinite, ilmenite, and also quartz. Each centrifuge treats around 195 meter cube per hour, or 240 tons per hour of tailings, wet tailings per hour. Typically, the solids throughput is around 70 to 72 tons per hour, and solids particle size is having a D50 of around 10 microns, so it's very fine particles, and the cake produced is around 55%, which is stackable. 55% might not sound a lot, but considering the nature of this material, it is a lot, and it actually produces a stackable cake. And the centrifuge is able to remove the fine clay particles from those mature fine tailings. And with the help of these centrifuges, this customer has actually used those recovered tailings for plantation and afforestation. So they have planted more than 3 million trees by using this solids cake coming out of the centrifuge that we have supplied. And just to give you an idea about how fine the particle size is, you can see this graph which shows the particle size. D50s, as I said, around 10 micron for the mature fine tailings, which is the brown graph that you can see up here, and the top size is less than, say, a few hundred micron. So it's very fine material, but it's being quite effectively dewatered using our solid bowl centrifuge technology. Now I would like to present this technology to you. So let's have a look. This is a cutaway view of our solid bowl centrifuge, and to give you a brief idea, this is the feed tube from where the feed slurry or the tailings enters the machine, and the red periphery is the solid bowl made out of stainless steel, and the feed slurry flows through the feed tube, and it gets discharged into the bowl from these windows, as we call them, which are in the conveyor. So this is the conveyor shaft, and it is hollow until the end of the feed tube, and thereafter it's a rigid shaft. And on the conveyor you have helical flights. So as soon as the feed enters the bowl, the suspended solids get thrown against the internal wall of the bowl by virtue of high centrifugal force, and then it's the duty of the conveyor to convey those solids and bring them out from the solid discharge port, which is located on the conical side of the bowl. And the clear liquid, after separation, it travels in the opposite direction and comes out from the liquid discharge ports. So this centrifuge has one main motor, which is shown on the right side or towards the feed tube, and it also has a smaller motor called the back drive motor, which is used for rotating the conveyor, and there's a gearbox in between. So this is how the solid bowl centrifuge cutaway section looks like, and this is called the bowl and the conveyor together. They form the rotating assembly, which sits on a frame, and that frame, all the four legs of the frame have anti-vibration pads under them. Because all said and done, the centrifuge operates or rotates at a high speed, and it does create little vibrations. For that purpose, we have equipped it with the anti-vibration pads. So let's see how the centrifuge works. This slide shows a centrifuge in operation. So let's have a look at this animation. So this is a feed tube, and then we remove the casing to show the solid bowl which is spinning, and now we cut the solid bowl to show you the conveyor, screw conveyor inside. So the feed enters from the feed tube, and it passes through the hollow shaft and comes out through the windows in the conveyor. And the clear liquid, after separation, travels down the length of the bowl and comes out from the other end, whereas the separated solids, they are conveyed by the conveyor and they come out from the solid discharge end or the conical end. So let's have a look at the animation once again to give you a better idea. So now the casing is opening and the bowl is spinning. So we have cut the bowl to show the screw conveyor inside. And this is the solid discharge end, the conical end. So the conveyor is conveying out the solids, and the clear liquid travels in the opposite direction. And this is how separation takes place in a solid bowl centrifuge. This is continuous separation. You can operate the machine 24/7 as long as you take care of the maintenance schedule. You can operate the machine almost throughout the year. So the availability, I can easily say, is more than 98%. So moving on to the next slide. Decanter centrifuge or solid bowl centrifuge technology has been existing since the past several decades, but it has not exactly become very popular in the mining industry, and there are reasons for that. You know, the old design of the centrifuge, it was what we call as a fat boy design, in the sense that the bowl had a large diameter but a shorter length, and it spun at lower speeds, and it was therefore not very effective in terms of solid liquid separation. But also in those days it was not equipped with the best quality of wear resistant material, and that's why the technology never really took off in the mining industry. But over the last few years, Alfa Laval has invested a lot in developing the design further, and they have now produced a solid bowl centrifuge that can give the highest throughput capacity in terms of solids handling, and they also, Alfa Laval has also developed the most robust wear parts. So these two facts have now started bringing back the solid bowl centrifuge back to the mining industry, especially for tailings dewatering requirements. So the USP of the Alfa Laval centrifuge is large machines with higher capacity. Each machine can handle up to 200 to 250 meter cube an hour of tailings with a solids load of 65 to 75 tons per hour per centrifuge. We today use what we have developed or what we call as the deep pond design and higher G-force. Alfa Laval has produced ultra high erosion protection specially for mining duties because we know the tailings can be very, very erosive. We have quite a few operating references now on mine tailings, and of course there are other benefits like lower power consumption. We have patented liquid discharge design, and of course the centrifuge also helps in water recovery, etc. So centrifuge technology has come a far way. It has evolved a lot over the last, I would say, a decade or so as compared to the earlier times. And that is how now it is being found useful to the mining industry as well, especially to dewater the tailings. So talking about the wear protection, the centrifuge is designed for tough mining duties. As you can see on the slide here, these parts that are shown in red, they are more prone to wear and tear because the centrifuge is a high-speed machine. So Alfa Laval has designed all these parts in tungsten carbide, and to begin with, at the feed, the feed zone, we have a fully covered feed zone made out of tungsten carbide. Then moving into the bowl, we have equipped the bowl with tungsten carbide ribs as well as other advanced wear protection. Then the conveyor, as far as the mining duties or tailings dewatering duties are concerned, we equip the conveyor with tungsten carbide ties across the full length of the conveyor, right from the conical end to the large liquid discharge end. And then the solids discharge ports are also an area where which is prone to wear and tear. So we have now fully covered solids discharge zone made out of tungsten carbide. We talk about the solids discharge port, the wear liners on the ball, the conveyor protection consisting of tungsten carbide tiles across the full length of the conveyor, and the solids discharge port. Yeah, and the first part here that I spoke about is the feed zone. By mistake, I said solids discharge. So, and this slide now shows the state-of-the-art automation that is being used for all Alfa Laval solid bowl centrifuges. There are bearing temperature sensors on both the conveyor bearings, temperature sensors as well on both the bearings, and we have bowl speed sensors, conveyor speed sensor. There's a load cell for calculating the torque and keeping it under control. And then we have developed a special software which is called as the Plus controller, which controls the operation of the centrifuge. So once the operator starts the machine, gives it the feed, slurry or tailings, and starts, the operator, all the parameters are set in the machine. The machine continues to run. It doesn't need any further operator intervention as such, and from that perspective as well, it's quite a good technology to have, especially when it's difficult to have skilled manpower in large numbers. The solid bowl centrifuge, we have seen how Rixs Creek has made the tailings dam redundant, making their operations more safe. So we say no more tailings dams, as safety comes first always. And of course, that also gives other benefits in terms of sustainability, and Alfa Laval is helping our mining customers to contribute to the UN sustainability goals through water savings or water recovery, reduction of waste, and reduction lower energy consumption. So these are some of the UN sustainability goals that Alfa Laval is helping our customers to achieve, like 11, which is the sustainable cities and communities, the 12 is responsible consumption, and 13 is climate action. So we saw how we talked about the centrifuge technology and how it has helped Rixs Creek to dewater their tailings and handle them in a better way as compared to their earlier days. Now let's talk a little bit about what the different kinds of technologies can do, because we know that there is gravity-based technology, using high rate thickeners or high density thickeners, as well as paste thickeners that can be used for handling the tailings. Then there are different types of filters. You have pressure filters or vacuum filters, belt presses, etc. And then we talked about the old decanter centrifuge, and of course now the new Alfa Laval decanter centrifuge. So this slide gives you a flavor of the particle size that can be effectively handled, or the sweet spot for the different technologies when it comes to particle size. So the gravity separation can handle, say, particle size from about 50 microns up to, say, 1000 microns, whereas the filters are have a sweet spot, say, between 20 microns and 200 microns. The old decanters could handle particle size ranging from, say, around 5 microns up to a couple of 100 microns, whereas the new Alfa Laval solid bowl centrifuge can handle particles right down to 1 micron in size. So from 1 to, say, 100 or 200 microns, the centrifuge can handle, and this is very, very useful, especially when it comes to tailings that contain a high quantity of clay. Just briefly, what are the different dewatering technologies capable of? So we have like the slurry, if it's to be just pumped to a large tailings pond, the solids percentage is quite low in that, and this can be achieved by using thickeners, etc. But if the customer wants to have thickened tailings, then they can go for high density thickeners, and if beyond that, paste thickening technology is available, but the highest solids concentration can be achieved using filters or centrifuge, the new solid bowl centrifuge from Alfa Laval. So the centrifuge also produces a thick cake, as can be seen from this picture, and this graph shows how the yield stress increases as the solids concentration increases. So the solid bowl centrifuge of today is able to produce a cake with, say, depending on the material, of course. If it is coal, it will be around 62 to 68% weight solids, and other metallic tailings, then the centrifuge can produce 80 to 84% weight percent solids with a high yield stress. So this is just to give an idea, and I suppose most of you are familiar with this. And then that brings me to the final slide for today, which shows the cake coming out from our centrifuges at Rixs Creek. So this picture gives a very good idea, because you can see that the cake is really, really very dry, and it can be disposed of by, say, co-mingling, or so it's much easier to handle. And today the customers who are adopting this technology, they are able to meet the strict guidelines set by the governmental authorities when it comes to tailings disposal. So with this, I would like to thank you for your attention, and I'll be happy to take questions in case you have any.
Thank you very much, Amol. I hope you enjoyed the keynote speech, and now we're going over to the Q&A session of this webinar, and we got some really interesting questions that have come in during the keynote speech, and I would like to ask you the first one, Amol. When it comes to ore recovering from tailings,
Yes.
Is that anything we can support with, or?
Yes, certainly. In fact, Alfa Laval has already started working in this area, and I can tell you, although we have signed up non-disclosure agreement with the client, I can only say that we have already done some test work on a particular project, which has yielded encouraging results. And further, we did some pilot test work, which has confirmed the initial trial results. And on that basis, we have actually supplied a few solid bore centrifuges for that project, which is basically for recovery of the ore from legacy tailings.
Okay.
Yeah, and there are millions of tons of such legacy tailings lying across the world, everywhere. I mean, in all the mining regions, and Alfa Laval has, I would say, the right technology to address that situation by helping recover those, the ore content in those tailings. And typically, in those kind of legacy tailings, the ore particle size is very, very fine. It's ultra fine. To give you an example, the particular project that I'm talking about, there the feed to the decanter centrifuge is 100% minus 10 micron in size, and we will help them recover maximum possible particles from it, which will add value to their business.
Yeah, yeah. We were discussing about ore here. Are there any other minerals we could take care of this kind of application or recovering?
Yes, I mean, at the moment we have done some work on coal, and we are also doing some work on gold tailings.
Okay.
So there are different kinds of legacy tailings, or even the tailings which are being generated currently, wherever the customer would like to either recover the ore or carbon particles, or anything of value to the customer, which until now was being sent as a waste stream.
Okay. Yeah. Yeah. Okay, thank you very much for that. Another question we've got is, I mean, we talk about capacity, and we talk when it comes to decanters, and one question is, what is the scale of the throughput?
Yeah, that is a very good question, in fact, because it's a common misconception that decanter centrifuges cannot handle large capacities. Well, in the past, the old centrifuge designs were such that they had their own limitations in terms of achieving the best performance, because they were kind of slow speed. Their ball rotating speed was lower than the new machines that have been developed, and then the design itself was not the best to facilitate maximum solids cake dryness, and maximum overflow clarity. So today Alfa Laval has designed this P3 design centrifuge, which is being now used in several mine tailings applications. And the specialty about this design is that it's the biggest machine, which has a bore diameter of 1 meter, has a very high throughput. In fact, I can safely say that it gives the highest throughput of all the centrifuges that are available on the market now.
Okay.
And it also helps in giving very good results by virtue of the deep pond technology that Alfa Laval is using in this design. So all in all, today our centrifuges are being used for very high capacities. And to give you an example, we have one such project in Canada, where 18 of these large centrifuges are in operation for the last more than 7-8 years. And every day, these machines are treating more than 30,000 dry tons of solids.
Oh, yeah.
30,000 dry tons of solids, I mean, coming from the tailings. So that's big installation.
Yeah. Impressive, I must say.
Yes.
Yeah. And then, of course, a lot of questions have come around the subject when it comes to cost comparisons, when it comes to for the different techniques like filters versus solid wall centrifuge and so on.
Yes, absolutely. And that is always an area of concern for every mining company. So we have done some study about this. On the basis of some of the installations that we have now for the past few years in handling or on this particular duty of dewatering mine tailings. And I would like to bring up a slide which shows some the capex and opex comparison between different dewatering technologies. So we have the paste thickener, the belt press, as well as the filter press or pressure filter, as it is also known, and the Alfa Laval solid bowl centrifuge. And you can see from this graph, the blue blocks are showing the capital cost, and from that you can see that the filter press is the most has the highest cost because it has a very large footprint, and typically it requires then much bigger building, etc. So the civil costs are quite high. So the capex on the filter press is the highest, and then it's followed by the paste thickener.
Okay.
Yeah. And if you see, then the belt press also is higher than the solid bowl centrifuge, because for a given duty, the number of belt presses required are quite high. For example, we are talking about 120 dry tons per hour of coal tailings on the slide, and that will easily require about 5 operating belt presses, 5 to 6, whereas only 2 solid bowl centrifuges are sufficient to take care of that duty. So all in all, when it comes to capex, the cost on the solid bowl centrifuge technology is lower than the other available technologies. And we can also say the same thing about the operating cost. And I have put here the NPV of operating cost for 20 years. 20 years is normally the lifetime, that's the minimum that we consider for solid bowl centrifuge, although there are centrifuges which are in operation even for the last 40 or even more than 50 years. So it's a very proven technology, but it has been now made more suitable for addressing the tough conditions in the mining industry.
Yeah.
And when we talk about the operating cost, this slide also shows that the operating cost for a centrifuge is also lower as compared to other technologies. And let's see the next slide, where we have given a breakup of this cost. So from this you will see that the belt press consumes the maximum amount of polymer. So the cost on the polymer for a belt press is substantially much higher as compared to a paste thickener or a solid bowl centrifuge. And when it comes to, say, the maintenance cost, the pressure filter costs are higher, because of extensive wear and tear to the filter cloths. So, and this data has been compiled on the basis of our interactions with different customers, mining customers, especially in Australia, and that's why the figures mentioned are in million Australian dollars. And from this slide, you can see for the paste thickener, the total cost, operating costs involved per annum works out to a little over 3 million euro. The belt press is slightly less than 5 million euro. Filter press, the pressure filter is slightly above 3 million euro again, and solid bowl centrifuge is slightly, very slightly lower than that. So it's more or less similar, but the advantage of using a solid bowl centrifuge is that it has a small footprint. The installation is rather, not so bulky, not so difficult to design and build, and it requires very, very less operator intervention. That is one of the major advantages of solid bowl centrifuge.
So labor cost is
lower as compared to the other technologies, because it demands very less operator intervention by virtue of the state-of-the-art control system that we have equipped it with.
Okay.
Yeah.
Yeah. Really interesting, Amol, to listen to this. And for those of you guys that are interested in this dewatering of tailings, I wonder what can they expect from us in the couple of months?
Yes, we are now working on fine-tuning all this information, and we will soon come out with a white paper on the centrifuge technology vis-a-vis the other dewatering technologies, and I'm sure that that information will be well received, because I know from my interaction with the mining industry and the mining community that many people are looking forward to receive, to get such kind of data.
Yes.
So,
and I just want to make a commercial as well, because I know that Amol is going to be one of the speakers at SME.
Yes.
Right? It's in Phoenix in February, so in a couple of weeks' time. So if you are there, please go to our booth, and if you have some other questions, don't hesitate to contact Amol. So
yes, I would be happy to hear from you and help you or assist you with any kind of information that you may need.
Yeah. So thank you very much, Amol, and you guys out there, thank you very much for participating. Hope you enjoyed it. Hope we answered a lot of your questions that you've got. If not, as we say, we are not far away. This webinar will be uploaded on meetalfalaval.com, and we will also have the presentation there available as of tomorrow. So with that, I say thank you very much.
Thank you, Magnus.
See you
thank
soon.
you, everybody.
Yeah, thank you. Bye-bye.
Bye.